Alright everybody, it's time to play everyone's favorite game show. It's, with your host, a Raspberry Pi with a tie.
Did anyone have mine higher still and better?
I can explain. What's up guys, welcome to our Tech Tuts, and today I'll be showing you how to make your own game show, complete with buttons, lights, and everything, using a Raspberry Pi. Yeah, that was the whole point of the intro. I'm sorry. Anyway, let's get to it. So, our game show will be face-off based, meaning two players will be presented a trivia question and will have to buzz in their answer as fast as possible. The Raspberry Pi will then light the LED corresponding to the fastest player. Then they'll have to answer the question. If they answer correctly, they get a point. Simple enough. Here are the physical parts we're going to need. First, a Raspberry Pi, a breadboard, some resistors, some wires, some push-button switches, and some LEDs. Let's put this all together so we can see what's going on first. On the breadboard, connect two wires to the negative rails. These will connect to our ground. Why are we using both sides? It's so we can make room for both the buttons and the LEDs. Then for both buttons, connect a resistor from ground to whatever row on the board you want, plug in the button, and then connect another wire that will go back to an input pin. For the LEDs, connect a wire emanating from the Pi, then before connecting the LED, connect a resistor from ground to the same row. Now take a look at the LEDs and determine the side that connects to ground. It's either denoted by the shorter node or by the flat side of the bottom. The other node should be connected next to the wire, since that's the side that's receiving the input. Now we can kinda see how this is gonna work, but before plugging things directly to the GPIO pins and possibly damaging the unit, let's write some code for managing the hardware. We'll save actually creating the game show logic for later, but for now, open up a new Python script. Import GPIO and time since it'll be important. Next, create a new class named BuzzerMatch that will have all the relevant methods to activate a new face-off. Since we don't want anything using this class to be needing the GPIO module, while still having the ability to pick the pin numbering scheme, create two static variables, GPIO board and GPIO BCM, which will correspond to the board and Broadcom numbers respectively. In the initializer, whose parameters will be the numbering schemes and the pins which our hardware will connect to, set booleans named needClean and reset callback to false, just so we know to clean up GPIO resources for later. Then make sure all the pins are different. If they are, save them to their own variables. If they aren't, throw an error. Then after setting the pin numbering scheme, set up the pins as inputs or outputs. For the buttons, type gpio.setup and in parentheses, the player button pin, gpio.in, and pull _up _down equals gpio.pud _up to give us a pull-up resistor. Since technically we have an open circuit when the buttons aren't pressed, the pull-up resistor will give a 1 in this situation. When the button is pressed, we'll get a 0. For the LEDs, type gpio.setup and in parentheses the player LED pin, gpio.out, and initial equals gpio.low. We set it initially to low so the LED stays off after this line. Now it's time for the play method, which will conduct and return the winner of the face-off. First, let's call a reset method, which we'll make later, and create a list named results containing nothing. Now let's add event detection so our buttons actually do something when they're pressed. Go ahead and type gpio.addEventDetect and in parentheses the player button pin, gpio.falling, callback equals self.disableCheck, and bounce time equals 300. This means when the signal goes to 0, it's going to call a method named disableCheck, which we'll write also shortly. And bounce time will simply make sure that the signal change is smooth. Also set reset callbacks to true between the event detection calls for the two buttons. Let's leave the play method for now to write disableCheck. DisableCheck has parameters self and the pin which triggered the callback. If the result list is empty, then add the pin to the end of the list. This lets us safely handle the case when a virtual tie was close enough that we can't properly disable the buttons. So, back to the play function. Start a try finally block so that we do stuff before returning the winner of the face-off. In a while loop, let's wait 0.3 seconds at a time when the results continue to be empty. Then read the first entry in the results, and depending on the pin, light up the corresponding LED. Then return false for player 1, and true for player 2, and also none in case something screwed up. In the finally block, which will be executed before the return statements, remove edge detection. Create a reset method that will put some random thing in the results. Remove edge detection if necessary, set reset callback to false, and turn off the LEDs. Next, create a cleanup method that calls gpio.cleanup if necessary. Then write a method named __del__ to call cleanup when a buzzer match object is destroyed, when, let's say, the program quits. Let's try running this in terminal. Pick some pins to plug the wires into, and let's do this! As you can see in the terminal behind me, you can see what's being returned by the buzzer match play method. It's kind of hard to see, but you can see something's being output and you can see the LEDs being lit. So, cool, we know it works. But we can't have a game show without a fancy display and some questions though. In this part, I'll be showing you how to use the model view controller design structure, meaning the code for our window and logic will be separated by a central controller. This is so we can make changes without breaking the whole thing in the process. In this case, the logic consists of the buzzer match class as well as the game show class we'll write right now. The game show class will just keep score and pick a random question from a list of tuples. The first entry is the question and the second entry is the answer. Then the window class will simply draw the display using tkinter and include some mutator methods to update it. Relevant event callbacks from the window will be to methods in the controller. The controller class consolidates the view and models into one. The most important method here is the next question method, which displays the question on screen, then starts the face-off. The winner of the face-off will be then marked on screen for them to answer the question. At the bottom, type if __main __equals and as a string __main ___ controller equals game show controller, so that when we start the program, we run that module first, we instantiate that class, and in the initializer it shows the window and all the fun stuff. Awesome. And now it's time to play everyone's favorite game show. Well, there's no name, but let's play anyway. Make sure everything's connected properly and plug in an HDMI cable to the Pi to actually see something. At this point, what happens is all up to you. Now, the program's only going to display the question and the correct answer. But, obviously, if a contestant answers incorrectly, you don't have to update his or her score. If you really wanted to go overboard, you could 3D print an actual button controller handle thingy that you actually see on television. What you do now, like I said, is all up to you. Awesome. Thanks for watching this episode of Eric Tech Tuts, guys. Hope it was cool, hope it helps, and I hope you learned something new. For reference, I'll have a link to a GitHub repository with all the code you've seen in this video down in the video description, and be sure to give this video a like, share with your friends, and be sure to subscribe for more videos like this and more. I'll see you later.